My name is Anton. I work for JetBrains. I'm not really involved into Kotlin development myself. I'm using Kotlin as a developer, and I feel it like it's a very convenient language to use for the purpose that I will be showing now in the presentation. So if we talk about the domain-specific languages, it means that they are kind of tailored for the specific task, right? So you design some sort of a domain, and you design the language around the domain, so that the language would be kind of limited to what we are doing right now with some task, or like you can probably come up with the examples of the DSLs, you know. Most likely it would be something like along the lines of building the projects like Ant or Gradle. This is something that comes up to my head at first when I think about the main specific things. But if we try to think of a theory a little bit, there are external DSLs and there are internal DSLs at the very high level. External DSLs is where you design a grammar, you design your own compiler, basically a parser, you create your own code generator, basically you create your own compiler. It feels like you're just creating a new language from scratch, right? And maybe it will be tailored for the specific problem. At JetBrains we actually have a tool for that. It's called MPS. It looks like this. So it's built on top of IntelliJ IDEA, and it has a very special editor, so when you create your grammar inside the tool, it actually generates the editor and generates its own renderers as well. But it's still, you are creating a new language. For the internal DSLs, it's not really fair to say that they are new languages. With internal DSLs, you're limited with the capabilities and with the flexibility of the host language. In our case, it will be Kotlin. Of course, if you have been interested in the DSLs in the past, you have seen probably that there are more languages that allow that. So basically, you can develop a DSL in Java as well. It is just limited in a way Java is limited, right? The capabilities of the syntax of the host language. But we stay on the dark side today, because Kotlin is there. And I want to show you a few examples of the DSLs that exist today already that you can take and use. And even if you don't know the Kotlin, the language itself, if you look at this example here, you can probably tell immediately what it does. It generates an HTML document, right? So create HTML is some sort of an entry point, and then you see a DSL-ish structure, which doesn't look like a programming language, but kind of a collection of blocks. Then another example is Anko, which is a library for Android development. You can specify the layouts for Android apps in that. And again, if you don't know Kotlin, it's pretty readable, and you can read and understand what it does. It's a form with 2 text fields and a login button. Another example is Gradle. So if you have been a Java developer or like in Java ecosystem, you probably have been using Gradle, and historically it has been Groovy to specify the build scripts. Now there is also a Kotlin alternative to it. Exposed is a small library for accessing the databases. So if you look at this example, we start a transaction, we create a table, we insert some value, and we iterate over the results of the select, right? So easy to read, easy to understand. Cardin is just some sort of a hobby project at GitHub for specifying the layouts and UI for Vaadin framework. One more, Kubernetes. So normally you would write a YAML file and hope that it's valid. But in Kotlin, you have a DSL to actually generate those YAML files. TeamCity is the project which I work with. It's a build server for building projects, Java, .NET, whatever. The configuration is implemented in Kotlin DSL, so we have our own Kotlin DSL for this purpose. And the last example I have here is an interesting one. So Ktor is a toolkit for developing web applications. And here in this example, you will notice something interesting, that there is a part of DSL that comes from Ktor itself, so it's related to routing. And the other part is actually the example we have seen on the first slide, right? So we are intermixing the DSLs within the same file. But why is it possible? It's possible because it's actually all valid Kotlin code, right? It's not that we are mixing two real languages coming from different compilers in one file. It's the same language, it's just the vocabulary that we developed for those two DSLs is a little different, and we can intermix as many DSLs in one file as we want. That's the beauty of it. So if you have been following carefully, you probably noticed that all those examples are very similar in a way. And how they are similar, there is usually an entry point that is followed by a block. And there is another entry, like the other nested block again. So there is like a structure of nested blocks in all those DSLs. And we can assign the values, we can assign blocks to values, we can use some syntactic sugar that Kotlin provides. I will probably later explain in my example why you would do that. We can of course create objects somewhere in between and call functions. And since it's in the IDE, it can be all syntax colored and nice and shiny, and when it really works, it looks like magic. So I have an example. You can actually find it in my GitHub account, but let's go over the code that I have and see how can we design a little DSL ourselves. For this example, I have a few Java classes in my project already. So it's a client with a few fields, getters and setters, nothing special. There is also a client builder that is used to assemble or compose this class. And like company builder, Twitter builder, and then the example code where it's all used. Right? If you read this code, there is nothing wrong with it. It's simple, everybody can read and understand what it does. And we are going to take this code and try to develop a little DSL in Kotlin for this one and see how can we transform it in small steps and learn about some Kotlin features along the way. So let me just copy it and paste it into the Kotlin file. When I paste it, actually the IDE will tell me, hey, you are pasting the Java code into a Kotlin file. We can probably do some transformations right away. Of course, I will accept it, and there are some changes already done for me. It's not idiomatic Kotlin code yet, but let's see what's changed. So there is no new operator. It's actually a compiler error. There is no type on the left here. So we had like a client here, right? Client, and now it's replaced with val. Then there is no semicolon. It's optional. Actually, if you put it, the IDE will complain and suggest to remove it. And setters, like setter call is replaced with a property assignment. But basically, if we come like navigate into the call, we will see that it's actually a setter invocation. And the very last one is instead of string concatenation, we have string interpolation in Kotlin, right? So it's the first transformation. There's nothing changed in a way that would reveal the structure that we have in the DSLs. And we are going to start transforming this code to get the structure and see how we benefit of it. Let's actually execute this code and see how it runs. The first compilation usually takes a few seconds. So the code executes, and there is a result, there is a string, created client is, and then a class reference, because there is no toString method in the class, right? And let's make an assumption here that all the Java classes that I have in my project are actually coming as an external dependency. So they are packaged, I don't have the source code, they are somewhere, like they're coming from some other project, I cannot change the source code, right? It's just for convenience that I have it in my project tree right now. Otherwise, I assume that I don't. And with that, like, what if I want to pretty print this client? Like, if you're a Java developer, the normal practice would be to create some kind of utility class, put in a static function there, like to console string, something like this, which will take the client as a parameter, client. So I'm actually writing Kotlin, but I'm writing Kotlin as if I'm a Java developer right now. And then it would return a string, and then return something like C Twitter plus, not Twitter, but maybe a handle, and then C Twitter, not company name, something like that. That's the way you do it in Java. In Kotlin, the idiomatic way is to use the extension functions. So the syntax is slightly different. You specify a type to which you are adding this extension function, and then we don't need a parameter. And then whatever is inside the body of the method has the access to the type that we are adding this function to. Yeah, so I actually have it in my project already, but I will just comment everything out. So that's the idiomatic way of doing it in Kotlin. But since we can go further and simplify it a little bit, say that since it's a one-liner that we have in the body, we can actually amend the type and remove the block and just have it like this, right? As if it's just the assignment. So the type inference works. It's a kind of a shorthand syntax for doing the same thing as we just had a moment ago. So instead of this, calling like a client now to pretty print the result here, we would have to invoke the toConsoleString method right here. And it looks idiomatic and nicer, but when you're designing a DSL, and usually you are designing a DSL for someone to use, or to reuse in your own project, it's usually a good idea to actually try to minimize the number of characters that the user will have to type. In our case, for instance, those braces are not needed. There are no parameters, right? Let's try to remove it. And in Kotlin, we have not only the extension functions, but also the extension properties. So instead of implementing the function here, we could do something like this. Val, say it's of type string, and it will be, we need a getter. Sorry. Yeah, it's not a function, it's a property. So already a small win. We are doing the transformations now, and they are not adding into our initial goal. We wanted to achieve this DSL-like structure, but those two elements, the extension functions and extension properties, are like the small building blocks that we will see how to use further to build up the DSL. Right? Let's check how it works. Am I cheating or am I not? Yeah, so we have the result. Fine. Now, let's proceed further and start building up the structure here. We're gonna remember that there are extension functions and extension properties. We are going to use them later. But remember, there was always an entry point to the DSL structure. Something like create document, create HTML, create something. In here, it would be create client. We are creating the client, so it will be create client. We don't have a function like that yet, but we do have a client variable already, so let's start with that. There is no builder, of course, at this stage, but there will be a create client. And we're gonna need a create client function here. And remember, like every entry point or a nested block there actually uses a block of code. And if you're a Java developer, a block of code for you is a Lambda expression, right? And in Java, if you want to implement a Lambda expression, you would use a functional interface. So for our purpose here, we could use a functional interface from Java, which is consumer. So if it should be parameterized. And since we are building the client, we are going to use the client builder as a parameter. If you're unfamiliar with consumer interface in Java, it represents an operation that accepts a single input argument and returns no result. So it will be a Lambda with a single argument, and it's going to do something with that and return nothing. There is no return, right? Okay, and to actually invoke the consumer, we need now to have an instance of this client builder, and have a variable of that. And then we need to pass it to the consumer. There is only the accept method that takes the client builder. And then once the operation is done, we have something inside the builder. So we can return the result from there. Client builder, build, and it's going to return an instance of the client. Good, we have our first entry point. And to implement it, we need an anonymous anonymous class. Client builder? No, consumer. Consumer of client builder. And we need to implement the accept method now. So it takes the client builder, and now we need to do something with that client builder to produce a client. And that code we have already written right here. So everything that was here, we can move into the accept method. And you already see like our first step towards our goal for creating the structure, right? We have nesting already. It looks ugly. Why? Because we have a functional interface from Java there, which is not idiomatic for this purpose. But it's like the first step. And when we have it there, you probably don't see it on the screen, but this part here is underscored with gray line. So the IDE will actually suggest to do something with Alt-Enter, and it will say that we can convert it into Lambda expression. But it's still like a Java-like Lambda expression, so it's a shorthand syntax in Kotlin for accessing the functional interfaces in Java. And we still have a consumer in there, which is a bit inconvenient. And in fact, since we are writing just pure Kotlin code here, we can skip creating a functional interface, because in Kotlin we have Lambdas as first-class citizens. All we need to do is to change the parameter here to accept not a functional interface, but a Kotlin Lambda. And we need to specify the signature for that new functional type that would match the consumer interface, right? So we need a functional type that will take a single argument and produce no result. How can we do that? We can just remove this functional interface the consumer and specify the type as we do that in Kotlin. So we have a functional type that takes client builder as a parameter and produces no result. And since it's Lambda, we don't need to invoke the accept method. We can just call it as a function, as if it is a function. And we can get rid of the consumer here. Right. So it's cleaner now. Now, at this stage, we can check one other feature of Kotlin. So if we are implementing a function, let's say foo, any function, it doesn't matter right now what is the name, which accepts a block of code. So let's say it accepts a lambda that doesn't have any inputs and doesn't produce any outputs. And if it's a single argument here, or the last argument, we could have some more, like something like ID string, for instance, right? So we have 2 arguments. In fact, we can invoke this function then like this, foo and some string and a block of code, right? And if it's the last argument in the list of parameters, we can actually move it out from the parameters list and invoke it like this, right? And if it was just a single argument, we could just invoke it like this without the braces. So this is exactly what is the IDE suggesting to do with our block right now. Oops, I removed too much. Yep. So if I do Alt-Enter, it will actually move out the lambda out of the parentheses and actually effectively remove the parentheses for that block. So we have our first block that we wanted to achieve. We have an entry point, we have a block of code that takes in a single argument, which is a builder, client builder, and all the rest of the code inside there. Now, if it's only single argument, we can actually remove, there is actually an implicit name for it. It's called it. And since it's an implicit name, we can actually skip typing it like this. The IDE will tell that there is an implicit name, like implicit variable with a name, like it, and it's of type client builder. And it looks much clearer now, right? So the only inconvenient part is that we have to access it or refer to it to assign some values and stuff. It would be perfect if I could remove it and have direct access to the first name. And I can do that. It's the only thing is that instead of it should be this. So whatever I refer to in that block should be in the scope of client builder. Now, to do that, we have a feature called lambda with the receiver. So currently, our method, the create client, takes a simple block of code like simple lambda, but we can say that this lambda should be executed within the scope of client builder. It looks like an extension function, right? It's a functional type, it's like a function, but it's a extension block for the client builder right now. And now if we go back to our code, we can see that the first name is now accessible directly. And the implicit receiver within this block is this instead of it. Nice. So we can actually get rid of those it invocations or it variable and access the variables directly, or the fields and properties directly for the client builder. And the first name, last name is exactly what I want here, right? Those 2 lines. We can proceed further and do some, basically the same trick for the rest of the code and see how it changes. So for instance, for this Twitter part, I could do it like this, remove the code. Now, we don't have a Twitter method yet, but if you follow carefully, you know now that the Twitter method should be a method of client builder. It doesn't exist yet, so it will be an extension method for the client builder. Function client builder, Twitter, and it will probably accept a block of code, and it's, since we are building up the Twitter part, and we had a Twitter builder for that purpose, it's going to be an extension to the Twitter builder. It doesn't need any inputs, and it will produce no result. Right. And now whatever we have within the scope of this method is actually happening within the scope of client builder. So we have direct access to the Twitter field. And all we need to do is now to use the Twitter builder instance to create that field, right? To assign, to create an instance and assign it to that field of client builder class. But we don't have a Twitter builder instance now. We need to execute that block that we pass into this method within the scope of Twitter builder. That's easy to do. We can create an instance and use the apply method from the standard library to execute a block within the instance of the class. It will execute this block within the instance and return the same instance back. And all we need to do now is to invoke the build method to get the instance of Twitter class and assign it to a field. So we are done here. And the block, you see, it compiles now. So basically we could do the same for the rest of the code like this. All we need to do is to just copy and paste this method, company, and use company builder instead of Twitter builder, and here as well, company builder, and assign it to a company field of client builder class. And we can transform this code here as well now. Move those assignments right here. We don't need the instance of company builder anymore. We don't need to access this variable as well. And basically we have reached our goal now here. We have transformed the initial code that looked, let's see how it looks split vertically. So we started with this code here, the code on the right, and we transformed it into the code that we see on the left. As you can see, the number of lines is slightly different, but we didn't win much really. What is the the benefit of this transformation that I see here is that the code on the left has definitely less characters, and it's kind of, you need to put less effort into understanding it because it has structure. So that's a big win. But we moved the complexity of this code elsewhere, right? We actually created a bunch of code right here to achieve this beauty. So what is the benefit? Why would I do that? So if you did this kind of transformation with your code only for a single purpose, like just to use it in your project, you actually introduced the complexity, you didn't reduce it. The benefit of it would be if I move this code into a library and give it for reuse, right? If I start reusing this code, then it's a great benefit. And a lot of DSLs that you see today are distributed as libraries, of course. So if we talk about the internal DSLs, the beauty of it is that we can extract it into a library and start reusing it. It's not a new language. You don't need a new compiler for that. And let me emulate it a little bit. So I will comment out the code I have written already. Let me close it. And I actually assume I have done this extraction, and I already have it in my different file, and I have added it into my project as a library, right? So I have all the same code here, all the same methods, but I have added something else as well, and I will explain what it is. Right. So if you are distributing your DSL as a library and you're giving it out to the users, you want the users to be safe and confident using your new library and your API. Because actually it's not really a DSL, it's an API. Your approach for designing the DSL is exactly the same as if you are designing the API, naming methods, naming variables, and so on. And you want the user to be safe when he's using the API, and it should be convenient for the user when he uses the ID, like to use the auto-completions. It all works, right? So, but the ID doesn't really know anything about if the code that you're giving to the user is a DSL. So you can actually help that. Suppose that you designed this, like we designed this DSL in a way that Twitter and company should not interleave in any way. So I shouldn't be able to put company into inside the Twitter block, right? Let me demonstrate what happens if I don't take any measures for that. So let me take this block and move it into the Twitter block. Nothing, right? Nothing happens. It's a valid Kotlin code. There is no compiler check that it's an invalid situation. But maybe the way you designed this code, that would produce a wrong result. It depends on what the code does internally here, whether or not it's a correct code or not. So suppose that I don't want this to be a valid situation. And there is a way to control that. If you go back to this library that I have here, so in Kotlin there is a way to control the receiver of the block within the block. So let me explain that a little bit. There is a DSL marker annotation which comes from the standard library from Kotlin. This one, DSL marker. But you cannot use it directly. It's a meta annotation. So you should create your own annotation and use this DSL marker annotation for your own one. So assume we are creating a client DSL. So we're going to use to create a annotation called client DSL here, with the assumption that I cannot change the initial classes that we use in our DSL, the client builder, and so on. I actually need to annotate those classes, but I cannot change the source code. What I can do here is to kind of extend those initial classes and annotate those instead. And then after this, if I do that like this, yeah, if I change my initial methods, the company and the Twitter, to use those new classes, so I'm using the annotated classes, right? The compiler will be able to check if those two blocks are interleaving and mark it as an invalid situation right away. So you will get a compiler error if you are doing something incorrect while using the DSL. So syntactically everything is correct, but we just gave the compiler an extra hint to check if the structure that we created using this DSL is correct. So like the users would not misuse my DSL that I just created for them. Plus there is an extra bonus for the thing we just did. We annotated not only the classes but also the methods. And now when we actually are calling out the completion somewhere inside the block that is participating in the DSL, you can see that the ID is telling us that we are inside the block that is supposed to be part of the DSL, And now the methods are sorted not just alphabetically or by the use, but there is an extra context to it. And it tells me, okay, company, Twitter, and create client are the methods that are part of that DSL, so we probably want to use those instead, right? And they are colored differently as well. That's kind of a safety and convenience in one. I think it's going to be improved even further, so there would be more means to control how the users are using your DSL and give some more hints on how to use it. But this is the current state of DSL support in Kotlin. Another fun part. So we are creating a client, could be a person. It is a person in our case, and person could have a birth date, right? Date of birth. So there is a field inside the client called DOB, and it's a local date. So in Java, it's a Java API, right? So it's a local date here. It's a Java time local date, right? So we are going to create an instance of local date here. This is how we do it in Java here. Let's say 2011, and no, it's too young, right? And we need a month, let's say November, and maybe 24 as a date. So if we do it like this, it looks like we have created the beautiful DSL structure here, and then we have an ugly API call right here. So maybe we could do something better. It was interesting, and I thought maybe we could do something fancy so that it would look like this: 24 of November 2001. Why not? And it's a perfectly valid Kotlin code. You can implement it like this with the same tricks I just showed you, but there is an extra trick. In fact, what I have just written here, the valid syntax is this one. So it's a function invocation. You might guess November is actually an extension function on an integer, right? So November is an extension function on an integer, which basically does the same thing as we did before. It creates a local date instance and returns it. But the fact that it receives only one parameter allows us to mark it as an infix function, and then for infix functions we can skip writing the dot and the braces. So it looks nice. But of course, the example I'm showing you is not a good one, because we don't have any control over the scope of the integer. We can type 42 there and have a November colon there on that instance as well. So it's not a good example. First of all, there is no control how the user will use it, and the second one, it's polluting actually the global namespace. We are adding a mix-in to a global class, let's say the integer. So it's not really good. Instead, it would be probably a better idea to have a special DSL, something like this, a date, and then create it as we did as nested blocks. But I don't have it implemented right here. So let's go back to the slides. From this demo, everything you have seen is a very simple documentation page, just a few pages of documentation actually, and it's titled as type safe builders in Kotlin. So everything I was explaining here is there. If you had to remember one thing from this talk, is that the Kotlin has lambdas with the receiver, right? So there is a type, and then you specify the functional signature after the dot. That's what you need. If you want to learn more, there's plenty of sources to learn from, and you probably know as you have tried Kotlin already. There is a new book by Venkat Subramaniam, which is a really good one. He also explains the DSLs a little bit in there. And of course, there is a playground for Kotlin, and there is a Kotlin chat where you can ask questions. On Coursera, there is a course for Java developers to learn Kotlin, and if you have questions for me, you can always reach out to me on Twitter. So I'm actually, I don't know how much time I have, maybe 10 minutes. I was too fast this time, but if you have questions right now, you can ask. I'm done here. All right, or we can go have a coffee a bit earlier. Yeah. All right. Thank you very much for listening, and I hope it was something you wanted and you learned something from it as well. Thank you.